So our subsequent question is to differentiate f of x is equal to 2x squared plus 5x plus 10. Okay, so the first note is that f of x is essentially like y. So we could just replace it with y here and just write out the same equation. We won't though, for reasons of practicality, so I'll show you. So say we do the first derivative, so if we differentiate f of x, we can simply go like this, which is much clearer than this, for example. And there's many other reasons why we do f of x. Okay, so to find the first derivative of our expression, the first rule is that we first cancel out all constants. So at the very end, our plus 10 goes away. The second part is that all x's also go away. So for example, if it's just x to the power of 1, like in this case, it simply goes away and just the 5 remains. If it's this example, so the 2x squared, the 2 goes down, right, and multiplies with the other 2. So we get 2 times 2, and the power of the x goes down by 1. So we get the following. So we end up having 2 times 2, so 4, and the x at 1 power down, so at the power of 1, and plus our 5. So let me show you another example to make this clear. So let's do example f of x is equal to 3x to the power of 4 plus 2x squared plus 19. Okay, so our first derivative of f of x is equal to the following. So firstly, our 4 goes down, right? So we get 3 times 4 x cubed, because our power of the power of 4 goes to the power of 3, and then the 2 goes down as well, so we get 2 times 2x, and then all constants go away, as I said, plus 0. So we end up having, this is a 12, right? So 12x cubed plus 4x, and that's our first derivative. We could continue doing this to do the second derivative, which is labeled as such with double prime, and this would then be with 3 going down, 12 times 3 squared plus 4, since the x would go, and this would then give us 36x squared plus 4. Thank you for listening.